Hi everyone, in today's video we will be explaining how to prove trigonometric identities. This was requested by a subscriber, so this is for you. Let's get right into it. Now then, up on the screen we'll find that we have a unit circle, and the most basic trigonometric identity we have is sine squared plus cosine squared equals 1. But how do we get that? So the first thing we have to realize is that y is the same thing as sine of theta. So y equals sine of theta. And x is equal to cosine of theta. Cosine of theta. Now why is this? Because you have to realize that sine is opposite over hypotenuse. So what's opposite to theta? Well, that's y. And what's the hypotenuse? 1. Y over 1 is the same thing as y. And so we can say that's sine of theta. And the same logic goes for x. Now you'll notice that we have a triangle here. And so what we can do is we can use the Pythagorean theorem to prove that y squared plus x squared equals 1 squared, aka sine squared theta plus cosine squared theta equals to 1 squared, or just the same thing as 1. So I hope you can make the connection that a squared plus b squared equals c squared, but we're just using these trig functions instead. And from this, you can actually derive a lot of other Pythagorean identities. For example, if we were to divide everything here by cosine squared theta, and cosine squared theta, then you'd see that we can actually simplify this into a new thing. We can simplify it into this. You should know that tangent is the same thing as sine over cosine, aka opposite over adjacent. And so just squaring that is the same thing as tan squared theta. Cosine squared theta over cosine squared theta, well, anything divided by itself is going to be 1. And 1 over cosine squared theta is the same thing as the reciprocal of cosine squared theta, which would be secant squared theta. And you can use the same logic to get a new one if you were to divide everything by sine instead. So let's go ahead and do that. So if we were to use sine instead, we'd see that this would simplify to 1 plus cosine squared theta over sine squared theta. Well, that's the same as cosine over sine, which is cotangent, because that would be the same thing as adjacent over opposite. So cotangent squared theta, which would be equal to the reciprocal of sine squared theta, which is cosecant squared theta. Now then, armed with this knowledge, we can go ahead and start proving some fundamental using trigonometric identities. So what we have to realize is that when we're proving something, we are to either start with the left-hand side or the right-hand side of the equation. So basically, if we choose the left-hand side, we want to somehow rearrange the left-hand side to equal this. Vice versa, if you were to choose the right-hand side, you want to rearrange it to prove this. So you're not solving anything, you're just basically, you can think of it as you're rearranging and kind of manipulating both sides of the equation to get your answer. With that being said, I will choose the left-hand side to rearrange and manipulate it into the right-hand side. So what I notice is that cosecant is the same thing as 1 over sine theta. So I'll rewrite it as that. 1 over sine theta times cosine theta equals cotangent theta. Next, what I can do is I can multiply the left-hand side to get cosine theta over sine theta equals cotangent theta. Now, what I notice here is that cosine over sine is the same thing as cotangent, because we're basically saying x over y, aka adjacent over opposite. Thus, we can prove that cotangent theta equals cotangent theta. Here is another example. Now, this might seem a little bit more difficult than the last problem, but as long as you're patient and you do your steps correctly, you will prove this correctly. So the first thing I want to do is I want to combine this. So I'll start with the left-hand side because I think it's much easier to manipulate into this than from this to that. So what I first see is that I want to combine these two fractions because there's two terms here, but there's one term here. So I want to get from two terms to one term. Now what I'll notice is that I can multiply both terms by the denominators. So what I can rewrite it as, if I were to multiply it by that and that, cosine theta plus sine theta cosine theta. And here I can say negative cosine. This is not going to be a positive cosine, it's a negative cosine since we have a negative sign here. So negative cosine times 1 is going to be negative cosine. And then negative cosine times negative sine is going to be positive because remember a negative times a negative is a positive. So cosine sine theta. And this is all going to be over. Well, what I see here is that this is basically a minus b times a plus b, which is the same thing as a squared minus b squared. So 1 squared minus b squared, which is the same thing as sine squared theta. Next, what I notice here, and this is where your Pythagorean identities are going to come into play. What I see here is a 1 minus sine squared theta. And if we look at the Pythagorean identities we conjured from the unit circle, we'll find that sine squared theta plus cosine squared theta equals 1. Well, that can be rewritten as cosine squared theta equals 1 minus sine squared theta. It's the same thing. See, 1 minus sine squared theta, 1 minus sine squared theta on this side as well. So what we can do is we can rewrite this as basically cosine squared theta. Now, next what I notice here is that we have a sine squared theta, cosine squared theta, and I see a positive cosine theta and a negative cosine theta. So we can actually just subtract those to get 0. Next, I see I have two. I have one sine theta, cosine theta, and another cosine theta, sine theta. You can actually just rewrite this as sine theta, cosine theta, because it's multiplication. So then next we can have 2 sine theta cosine theta all over cosine squared theta. Next, you can cancel out one of the cosine thetas. So then now what we have is 2 sine theta over cosine theta. Because remember, we're squaring it here, but there's only one of it here. And now we'll realize that this is sine theta over cosine theta. So we can rewrite this as 2 times sine theta over cosine theta. And you'll realize is that sine theta over cosine theta is the same as tangent. So that means that this can be equal to 2 tan theta, which is the same thing that we were meant to prove in the beginning. Alright guys, if you guys enjoyed that, go ahead and leave a like, subscribe, and comment down if there's any other things you need help with. I'll see you in the next one. Bye.